Now imagine that you are a biochemist attempting to characterize the kinetic behavior of a new mutant of the motor protein kinesin. You will need to set up reaction tubes and collect data to determine the values for Vmax and Km. You will be monitoring the ATPase activity of the kinesin by quantifying the conversion of radio-labeled ATP to ADP. First, prepare 6 1-milliliter reaction samples. Use the micropipetter to add samples dropwise to the tubes. Be careful, sometimes the order of addition matters. Be sure to leave room in the tube for substrate, and do not add substrate to any tube until all samples are ready. While computers can easily determine kinetic parameters from a hyperbolic Michaelis Menten plot, these graphs are unwieldy for visually estimating values for Vmax and Km. For this purpose, the Michaelis Menten equation can be rearranged to a linear equation with the form y equals mx plus b. The resulting plot is called a Lineweaver Burk, or double-reciprocal plot. Km and Vmax can be readily obtained from the x and y intercepts of a Lineweaver Burk plot. The y-intercept is 1 over Vmax, and the x-intercept is -1 over Km. Chemical kinetics and enzyme kinetics are related, but because of the complex of enzyme with bound substrate, enzyme kinetics only correlates well with chemical kinetics in the extreme cases with very limited substrate or vast excess of substrate. Michaelis Menten enzyme kinetics describes the behavior of enzymes over a wide range of substrate concentrations. 2 important kinetic parameters are Vmax and Km. Vmax is the maximal velocity of an enzyme-catalyzed reaction at saturating substrate concentration. Km is loosely related to substrate affinity, but a more correct description is that it determines the shape of the Michaelis Menten hyperbolic curve. Kinetic experiments can quantify how the rate of an enzyme-catalyzed reaction changes with the concentration of substrate. Data obtained can be plotted and fit to the Michaelis Menten equation, or rearranged into a double-reciprocal plot. From these graphs, the kinetic parameters Km and Vmax can be obtained.